we often have this issue. We need to get something out quick, and we need to have something that people can touch, understand, feel, and get some feedback on. So you end up with the bad design approach where it's easy to do things at the start really quickly. So there's a lot of net new functionality, things come into picture, and you're able to test and manually test it and get a feel for it. It's basically everything passes the vibe check. But as the project goes on and the software life cycle is either coming to an end or we're entering a new phase of maturity, we reach that plateau of frustration. And that's when it takes just so much time to add new functionality because you have to do so much thinking about if I touch this piece, what will it impact? Can I do a refactor here? When you refactor something, it breaks a lot of tests. And the code is often a lot of spaghetti code that's thrown together by someone who has a lot of tribal knowledge, and you can't really make changes there. So it becomes very difficult to extend the functionality of the software to build anything meaningful beyond those early days where the bar was very low, but it was easy to show stuff. Now that the bar is higher in terms of quality that the software needs, it's very hard to add things and it's very hard to change things and go back on bad decisions that were made early on. So you end up in a place where you have two options. One is start from scratch and just code it the right way. That's valuable too. You could do that. Sometimes the project's too far gone. You just got to scrap it, take your lessons learned, start over. But what I think happens more often than not is people continue to piecemeal the solution together. And the reality is, if you had in the beginning started with some first principles, you don't have to start with all of them, but started with some first principles and built with some design in mind, you would save yourself at the end of the project the headache and frustration of trying to complete that last 20%. This is what I call like traditional application development, which is the scenario we just talked through. You might have a front end, you have a server, and you have two places where state is being tracked, maybe some Redux up here, and then the back end is a couple databases and a NoSQL database, whatever you needed to get the job done. And over time, you have to do patches and upgrades, so things are changing on this server while you're trying to do everything that's driven from the front end. So all requirements are driven from the front end and those interactions with the user. So you don't really have time to really model out things correctly on the back end. And also you have a separate infrastructure that you're responsible for. So on the front end, when they can't have the back end make changes quickly enough, what usually happens is they go out to some type of third party and use that as a tool to do the work, maybe some SaaS tool. And they also use some type of black box infrastructure to make up for the infrastructure on this side not being enough. And you end up in a place where now when it's time to make changes, you don't know where to make changes. Do we make it here on the front end? Will that propagate throughout the system? Do we make the changes here in the servers? How will these patches and upgrades impact the front end and the state of this and the third party of here? And what do I need to do with this black box infra? I can't monitor it. There's no visibility into it. There's no tracing. And so it becomes really hard to reason about this system. And when it's hard to reason about a system, that's where you start to feel the frustration of, all right, let's just throw it out for something that we can actually reason through. So I've come up with 3 set principles here. It's not groundbreaking, but the 3 principles I try to follow when I move into a rapid application development phase, but I also want to make sure I have somewhat good design. One is that state, schemas, and infrastructure needs are explicitly defined in like a well-known language. So something like TypeScript, Python not as much because it's dynamic, C#, Java, even Terraform. I'm not a big fan of HCL, but anything that's like a language you can read and update via version control, you want all your state schema and infrastructure needs to be in that because it's easy to look at a glance and it's also easier to reason about. Now, there's different scales of that. The next one is you want to make sure if you're going to use third-party tools, you understand the behavior very well. If you're going to use a third-party tool, a good rule of thumb is to understand the layer below it. So understand what it's actually automating away, the magic that it's doing for you. And you want to make sure that you can mock it, test it, and swap it off if needed. There are so many times where I've used a third-party tool thinking it's the greatest thing on the planet, and then 6 months later, either the maintainer gives up, the startup goes under, or there's some bug in the tool that cannot get fixed in time, And now I'm left with a big hole in my architecture that I can't fill because I used this third party thing. And it's really tightly embedded. So the entire project is now at risk. So making sure that you can mock it, test it, and you can swap it out whenever you need to is very important before taking on some third party managed tool. And then you want to also make sure the core components of your system are composable. This is because if your core components are tightly coupled, it makes it hard to detach them later on when you want to go to maybe a microservice architecture. And if you have a monolith that's going out of whack because of cost or going out of whack because of security needs and pop configuration needs, and you can't move pieces of the system in and out, makes it very difficult to actually do a refactor because touching one place will maybe cause irreparable damage in another area. So you have to think very carefully about making changes as the software grows over time. This leads into the idea of everything as code. You're able to make these changes quickly without having to log into different dashboards, consult with different vendor teams, try to understand the downstream impacts of not using this tool and using that tool, or having to deep dive into different framework libraries to make sure things are working as expected, or look at different people's roadmaps and deal with their opinions. And this is not a new idea. I think it's been around for a while, especially with infrastructure as code being something that's more and more popular. This is just a quick image that shows this idea. So everything is in source control, and you can track compliance, you can track artifacts, security, apps, infrastructure policy, and workflows. So instead of being worried about making changes to your application, your infrastructure, your backend, you can be confident about making those changes, and you can be confident about making those changes quickly and rolling them back if it's not the change you wanted, or testing out different types of changes. When you have everything as code, you're able to explicitly define your entire system as code iteratively. So you get version control, you get nice testing, and you have more confidence in the software that you're writing. So I went through what bad design is. What is good design? So good design for me means you might have a slow start in the beginning because good design requires that you have some strategic upfront thinking, which means you're not coding. In some sense, you're writing things down. Maybe you're talking with people, doing some research, trying to figure out what's the right way to do things, reading other people's code who've done the problem, who've built the solution. But you start to ramp up at a good steady pace, and eventually you might hit a plateau of frustration. Now, if you're a 10x developer, you might skip this altogether, but I've realized at some point you hit some type of plateau of frustration within any project. I don't think it's avoidable. But the difference here in good design is when you reach that plateau and you've done some good design up front, you have a robust set of tools to get yourself out of it. Now you can really think about how are we going to add in new interfaces to make sure that the project works well, still has all the behavior it had in the past, still is backward compatible, all of the things, but we want to add net new functionality. And eventually you'll get out of it and move into a space of rapid experimentation. This is like the pinnacle of where you want to end up with your software product is you can quickly make changes, and even in quickly making changes, you can quickly roll them back. That means you can now compare two changes in real time and see which one is better. So this is commonly called A/B testing. This is used in the marketing world where they put up a landing page. They might tweak a little piece of it, show both of them to different portions of traffic that's coming into the website, and whichever one performs better, that converts better, they use that one, and then they roll back the one that didn't perform. And so they do that over and over again until they get the best version of the landing page. Now, if you are still struggling to refactor your application, to fix bugs, and you're stuck in the bad design area where you can't even add like a net, you can't even change the headline on a website without a massive, complex operation, then you are not going to be able to do rapid experimentation at all. And it would not be advisable to do that because you'd break a lot of things. But what this requires is a flexible infrastructure layer, something that can quickly change and redeploy. You need to be able to have security controls and policies. And so when you make a change, you can quickly check if all of those things are still in line. So that's the approach I've been taking recently with different software products that I'm building. is I want to make sure everything is in code. I want to make sure that I'm following some principles from clean code, hexagonal architecture, and microservices architectures, and using the best parts, maybe leaving behind some of the parts that require me to write too much boilerplate. But it's ultimately up to you to pick what principles work for you and what style works for you. But I would advise against throwing spaghetti against the wall. That's where you don't want to be, because you just end up being frustrated much later with your project overall.